Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you a quick introduction to normal distribution and standard normal distribution. So normal distribution has a bell-shaped curve. It is symmetric around the mean, so the mean is going to be at the peak. Okay, so this is the mean, and the rest of the data values are going to be distributed evenly on either the left hand side or the right hand side. And if let's say you have this long sentence of a random variable that has a normal distribution with mean mu and variance sigma squared. Now this long sentence can be mathematically represented as for example, random variable here, we can represent that with capital X. So capital X represents the random variable, has a normal distribution with mean mu, so this is the position for mu, and variance sigma squared. So this long sentence has already mathematically represented using this notation here. So whenever you see this notation, basically it means you have a random variable X that has a normal distribution with mean mu and variance sigma squared. Okay. Now, mu and sigma squared here are the parameters, and if you change the values of the parameters, the graph will also change accordingly. Okay, so as an example, if you refer to the graphs given on this page, this is the normal distribution curve, the blue line here, and you can see that the mean is at 0.0, so this is the peak of the distribution at 0.0, and the variance here is 0.2. So if you look at the rest of the values here, 0.2 is the smallest, and therefore again, if you don't remember, variance is the measure of dispersion, or in other words, how large is your data spread out. In this case, the value here is very small, so compare this with the rest of the curve. This one will have the smallest spread of data, okay, 0.2. Now if you consider another normal distribution curve where this is at 0.0, the mean is at 0.0, okay, and this one has the largest variance, which is 5, and therefore you can see that the data is spread out. That is the largest spread compared to the rest of the distribution. Okay. Alright, now let's look at the standard normal distribution. So the standard normal distribution is a special case of normal distribution where the mean is going to be 0 and variance is equal to 1. It can be mathematically represented as such, and because the variance is 1, of course, your standard deviation is also going to be equal to 1. Now, this is the standard normal distribution. Since we have here the mean is equal to 0 and the variance is equal to 1. Okay, the standard normal distribution. Now, the area under the curve is 1. Okay, so if you have a standard normal curve, the area under the curve is going to be equal to 1. Alright, now let us revisit the idea of calculus, the idea of integral calculus. If you have, for example, this is your x-axis, horizontal axis is labeled by x, and this is your vertical axis, which is labeled by fx. And let's say you have this particular curve. Let's say that you have this curve, so that can be represented by fx. Yeah, the curve is given by fx, and if you consider the point a and b, and if you integrate this function fx with the limit from a to b, what you get is you will get the area under the curve. So in statistics, the area under the curve is also known as probability. Okay, so what is going on here? Now, here is the horizontal axis. Instead of label as x, the label here is z. So the same thing for this one. This is the vertical axis, which is labeled as fz. Now, this is the curve. The curve here doesn't touch the z-axis. Okay, it goes very close, but it doesn't touch the z-axis. And the curve here is described by this function here. So we have this one. Okay, it doesn't look pleasant. It doesn't look friendly at all. So you can imagine trying to integrate this function in order to find the area under the curve. So basically, the answer is going to be 1 when you integrate function fz, which is this one. You integrate this function with respect to z from the negative infinity, the lower limit, to infinity. Okay, because it doesn't touch the z-axis, it goes on. Okay, right. So once you are able to integrate this, the result is going to be equal to 1. So that is what it means by this statement given here. Now you can imagine that if I want to find the probability, for example, from what is the probability the random variable z is between 1 and 2. So basically it means from this area until this area. So I need to integrate this function, and the result of that will give me the probability that I'm looking for. So the same thing, if let's say I want to find the probability from 0 to negative 2, that means my lower limit is going to be negative 2, my upper limit is going to be 0, and I have to integrate this function from limit negative 2 to 0 in order to get the probability. And like I said just now, this is not exactly a friendly looking function. It's not exactly easy to integrate this, and you can imagine the amount of work that you have to do in order to find the probability. But we don't have to do that anymore, because the result of this integration are now given in the standard normal distribution table. So that is the essence of the standard normal distribution table. Basically, it gives the result of the integration process that you have to do here in order to find the probability. Alright, I think I will stop here, and I will continue in the next video on how you can use the standard normal distribution table to find the probabilities and the z values. Thank you very much for watching.